Okay, lecturette 5. We are going to talk about what happens under times of stress. How does our body cope with stress in regards to metabolism? Now, what we're looking at is an old slide, right? So we're showing you what's going on in regards to metabolism of sugar, right? So what I want to do now is bring in some players that come online when our body is stressed. And so they're stress hormones, right? So we have cortisol and we also have epinephrine. Any adrenal hormone is fine. Norepinephrine too, but let's just keep this simple, okay? Cortisol and epinephrine. Now, epinephrine, right, when we're stressed, remember the whole point of stress, right, is to now engage the sympathetic nervous system to shunt blood to our muscles, right? So we can respond to some type of an emergency. But you need nutrients to run those muscles. And so the whole point of stress hormones is let's break down macromolecules to get monomers to run said musculature, all right? And so here, what you're going to find then with epinephrine, it also has the ability to turn on the enzymes to break down glycogen into sugar. So we have increased sugar in the bloodstream, just like glucagon, okay? Now, it shouldn't surprise you then that epinephrine also can allow us to upregulate enzymes to let us now break down fat in adipose cells so we can release free fatty acids. Now, let's talk about cortisol. Cortisol is a promiscuous hormone and it binds everywhere. Now, cortisol also binds to the liver so that we can now get glycogen to be broken down into glucose and released into the bloodstream. Cortisol can also bind to adipose cells, so I can break down fats and release free fatty acids. Here's something that cortisol can do on its own, right? Cortisol is the only hormone that when it binds to proteins, okay, it will now cause you, protein cells, it will cause you now to upregulate enzymes for you to catabolize your own structural proteins, okay, which we do when we're very deficient in proteins. Now, if you didn't eat any proteins all day or 2 days, right, your body's going to be in big trouble is because remember what enzymes are, right? Enzymes are proteins. And if you don't have enough amino acids to make new proteins, to make new enzymes, to repair enzymes that are degrading, you're not going to be able to run metabolism in your body. And then you're going to die. So cortisol can break down your structural proteins of your body to provide the amino acid source. Now, I want to show you folks, this again is an old slide. All the slides are repeating themselves. I'm just adding to your knowledge. And what I'm going to do now is just show you, and let me change my color so I have something a little bit different. Now, in the liver, I gave you the mechanism of what glucagon is doing. Glucagon is binding to its receptor to allow me now to upregulate and activate enzymes that are responsible for glycogenolysis. Guess where epinephrine is binding? Yeah, you guessed it. Same place. Okay, so this is the same mechanism here. So this could either be glucagon or it could also be epinephrine. Cortisol has its own receptor, okay? It may also be epinephrine. Now, what I want to show you is let's talk about cortisol. So cortisol is one of the many molecules that falls under this umbrella term called glucocorticoids. There's a lot of different stress hormones. Cortisol is the main one in our body. It's not the only one that we have, but it's the only one I'm going to talk about right now because this is not an endocrinology class. So glucocorticoids, aka, and I'll just put, where's my red? I'll go back to red so we can see. Thank you for your patience. Okay, here we go. So glucocorticoids, and an example of one of these is cortisol. Another example of a glucocorticoid is hydrocortisone or prednisone. There's a ton of them, okay? So cortisol. Glucocorticoids. Now, glucocorticoids, when it's secreted, this is a hormone, okay? This is a steroid hormone. And what it can do now is allow you to have the breakdown of glycogen. I just showed you that, okay? And then if I run out of glycogen, I can make ketones. And we talked about ketone manufacturing in the beginning of the semester. Now, what cortisol also helps you do in an emergency state, it allows you to break down muscle, okay? If I break down muscle, I can utilize that amino acids for whatever I need to make enzymes, and I can also convert amino acids into glucose, okay? Now, glucocorticoids also counter the effects of insulin, yes? Because remember, glucocorticoids act in the same way that glucagon does. Okay, so remember, insulin and glucagon are opposites. They have the opposite effects, which means that insulin and cortisol will also have the opposite effects. Now, glucocorticoids, such as cortisol, can also promote the breakdown of fat. I showed you folks that in the previous slide. Okay, and then here, this last function is it also can cause you to reduce bone formation. Okay, so let's expand upon that. Now, I'm going to talk about a condition called anorexia nervosa to explain what goes on with the breakdown of bone density. So there's a condition called osteoporosis, and osteoporosis is defined by losing bone density. So what you folks are seeing here on the left is the trabecular struts that make up spongy bone that's supposed to make your bone very dense and hard. But if you have osteoporosis, what's happening is the calcium is starting to degrade away, and people that have osteoporosis tend to have bone breaks very, very easily. Now, let's talk about this. So in this condition, right, anorexia nervosa this is a eating disorder, and this is when individuals don't eat, right? So this is a starvation condition. Right? So they don't eat for long periods of time, and your body is now under stress, right? So if your body is under stress, you're going to start to increase cortisol levels, okay? And you already saw from previous slides, if I increase cortisol levels, I'm going to start to undergo catabolism, right? So I start to catabolize glycogen. I start to catabolize fats, right? And then last case scenario, I start to catabolize my protein mass, my skeletal protein. So in this individual, you can see that they've lost their fat, interstitial fat, a lot of their muscle, right? I can see the hip bone in here. And so what happens now in regards to protein is that when you build bone, right, first you have to lay down collagen fiber. Okay, so this is collagen fibers. And then on top of the collagen fibers, that's when you can put bone on top of that. And I'm just going to put it like a green. Okay, and so what this green is, these green dots is just me drawing some calcium phosphate groups on here. So what I'm showing you is the trabecular struts, and after you've now laid down collagen fiber, then you can lay down calcium on top of that, right? So I'm drawing for you how we make bone. Now, guess what? Under times of stress, high stress, and if I'm already now taxing all the skeletal muscle, I'm going to go after every protein in the body. Doesn't discriminate, right? Cortisol doesn't discriminate. If you're protein and we need that, we're going to break you down. So what happens now is the protein, collagen fibers are protein, right? Your body starts to break down collagen fibers, okay? And so the calcium starts to fall off. That's one way where high cortisol can lead to decreased bone density. Another way is the following, right? So let me change my pen color back to the original. Now, what cortisol does and we'll talk more about this when we get to reproduction, is cortisol has a really, really strong mechanism that shuts off all of the sex steroids in your body, or lowers them, I should say, not shuts them down. So here, what's happening is if I have elevated cortisol, it will now lead to decreased estrogen, and estrogen is responsible for maintaining bone density. Okay, this is why, especially women, as we start to age, we are more prone to osteoporosis, is because we lose bone density at a high rate, which can lead to osteoporosis. All right, that is it for this lecturette and this lecture. We are Paul Kopapa, and I will see you folks on the other side next week. Goodbye.